Okay, that brings up number 16. Told that Dave uses the equation 15m equals 165 to calculate the amount of money he earns each hour he works. Which step should Dave use to solve the equation for m? Let's write down what we have here. We have 15m equals 165. 15m equals 165. And we can see that there's a multiplication implied here. It's 15 times some number called m, money per hour, for example. 15 times m equals 165. And they want to find out what step we would use to solve this equation for the letter m. Well, the step that we would use, because we have multiplication on our left-hand side, we would simply take this 15m and divide it by 15. So we end up dividing both sides of this equation by 15. And that's 15. Divide both sides of the equation by 15. And if you do that, you're going to end up with a number which is a little over 10. Let's see. Well, we can take this 15, put it into this one time. We end up with 1 left over. And we're going to end up with 11. So 11 times 15 is 165. So this looks like this person earns $11 per hour. They worked 11 hours and they got $165. Not bad. Let's look at this one. This is number 17. The formula to convert Fahrenheit to Celsius is Celsius equals 10 times Fahrenheit minus 32 divided by 18. They're telling us that the temperature outside in Fahrenheit is 41 degrees. And they're asking us to make the conversion to Celsius. What is the temperature in Celsius? This is one of these things where we have to use order of operations. Please excuse my dear Aunt Sally. And this board is completely, excuse me for a minute, this board is completely off. Okay, I hope that takes care of that. Reorienting the board. Let's try that again. Yeah, this is where we need to use the order of operations. Please excuse my dear Aunt Sally, where this is going in order of precedence, importance, from left. This is the most important to the least important, addition and subtraction. When we run into addition and subtraction and the same problem, we just work it from left to right in our problem. They have equal precedence. So the first thing we have to do is we have to get this Fahrenheit. We take this 10 and we take our Fahrenheit degrees, which is 41 degrees, and we subtract 32. And then we divide by 18. Okay, so let's do this. We do what's inside of our parentheses first. 41, take away 32, and we end up with 9. And now, following our order of operations, we have a multiplication and we have a division. Multiplication implied here and division here. So we do our multiplication, we're working left to right, we do 90, and we're going to divide that 90 by 18. And 90 divided by 18 is equal to 5. So that would be 5 degrees Celsius. 41 degrees, which is pretty much the temperature it is today. That would be 5 degrees Celsius. That brings up our next one. A radio station plays 15 songs each hour. At this rate, how many hours will it take the radio station to play 75 songs? Okay, we're doing 15 songs an hour. And we're looking for how many hours will it take to play 75 songs? Well, we do 15 songs per hour. How many hours will it take to do 75 songs? Got a problem here with my notation. It's 15 songs per hour. It's just 15 songs per hour. How many songs can we do in how many hours will it take to do 75 songs? We have 75 songs. So we have 15 times x. How many hours will it take to do equals 75? And what we do is we have 15 x equals 75. So we just take this 15x, divide by 15. We divide both sides by 15, and we end up with x equals 5. So it's going to be 5 hours to play those 75 songs. 5 hours to play the 75 songs. Jacob went to eat at a restaurant. He graphed the total cost of each meal, how much he gave as a tip, which describes the rate at which he the amount of the tip changed. So this board is not cooperating. Let's see if it's better over here now. And what you have is this is the amount of the tip. And this is the total check. And if you look, you have a linear relationship. It was a straight line which goes up like this. And we'll just take a couple of points here. We have 5 here, 10, 15, and then we have 20. And then on this axis, the y-axis, we have 1. And then we have 2 here. And we'll say we have 3 here. And let's just see, we really only need 1. We really only need 2 points. But we can go to 5. We'll go to 5 and we'll see where this 5 is. The 5 is at 1. 5 is at 1. And our 10 is at 2. So what has happened is we've gone over this way $5, and we've gone up $1. So for every total in the amount of the check, for the total of the amount of the check, as it goes up for $5, we're increasing the tip by $1. And that corresponds to letter C. It increased $1 for every $5 increase in the amount of the check. This is a mode problem. It says find the mode for this set of integers. And we have 650, we have 4 750s, and we have some other numbers here, 875, 900, 925, and 2,900. So our mode here is this. The mode is simply the greatest frequency of data points. So we have 4 of these data points, which is 750. And the only thing that comes anywhere close to that would be there's 2 data points over here, 925. But clearly the mode in this case is 750. We have 4 of them. And that would be the answer for that one. 750 is our mode. Let's move on to the next one. A bowl contains 13 numbered cards, 1 through 13. Josh randomly selects 1 card from the bowl. What is the probability? The card has an even number on it. Well, he has 13 cards, numbered 1 through 13. So he has, and we're looking for the evens. So the evens between 1 and 13 are 2, 4, 6, 8, 10, and 12. There are even numbers. And we have 1, 2, 3, 4, 5, 6 of them. We have 6 even numbers over 13. That's our total answer. By the way, this is wrong. This should be written like this. As it contains 13 cards, so it will be written like this. This means the set of numbers from 1 to 13, including the endpoints 1 and 13. So we have 13. We have a set of 13 numbers, and we're taking 13, the set of 13 integers, and we're taking the evens, 2, 4, 6, 8, 10, and 12. That's 6 over 13, and that would be our answer, 6 over 13. That corresponds to letter A. Letter A, that's number 22. That brings us up to the next one. This is number 23. The arrow on the spinner is spun once. What's the possibility or the probability the arrow on the spinner does not stop on green? If you spin this around, there are, let me see, there's four places that spinner could land, and they're looking for the one, does not stop on green. So there's 3 which will stop on green. and there's 1 out of 4 which will stop on red. And this is the one we're looking for. The one that does not stop on green. 1 out of 4. And that corresponds to letter A. Letter A on our answer sheet. This brings up number 24. And what number 24 talks about is something that you need to be aware of for this upcoming test. And it's something called experimental probability. And there's 2 types of probability. There's one called experimental, there's one called theoretical. And the theoretical possibility is the one you can figure out using math. Sometimes when you do an experiment, it works out that your experiment is different than the theoretical or the mathematical probability. And if we look at number 24, we're told that a box contains 5 cards, letter A, letter J through N. A card is randomly selected from the box. The letter on the card is recorded and then returned to the box. So each time, and then it says the bar graph below shows the number of times each card was selected during the experiment. Well, if all things were even, we would expect, well, actually, we would actually expect, because there are 5 cards, theoretically, when we go up to select a card, there's 5 cards, and we make one choice, there's a 1 in 5 chance, or 20% probability that we would select any card. And notice that they're telling you that on the selection of each card, they put the card back in the box. So there's always, prior to selection, there are always 5 cards. However, if you notice on our graph, on page 14, number 24, our graph shows that there is a distinct favoritism in the experiment. That is, when they've done this a number of times, they've done it at least, let's say 9. I see they chose at least 9 times, because there are 9 instances where L was chosen. 6, 9 and 6, 15, 5 is 20, 23 to actually perform this experiment 25 times. And out of those 25 times, L was chosen 9 times. But the letter that we're concerned with here is the letter M. And if we look at out of the 25 times, M was chosen out of the total of 25 picks. M was chosen, let's see, 5 times. And that 5 times would equal 1/5. And that 1/5 equals a 20% of the time. The M was chosen. So in this case, the experimental probability and our theoretical probability match. However, it's plain that in the case of L, they don't match because it was chosen 9 out of the 25 times, not 5 out of the 25 times. So it's important when you're looking at experimental probability that you actually count up the total number of picks and then look at your chart to see how many times that element was chosen. Number 25, that brings up number 25. This is a circle graph. It shows how the students at Lakeland Middle School travel to school. If you look at this, you can see that they go by bike, bus, walk. Some of them go by car. If there are 500 students, how many go to school on their bikes? Well, this is a pretty simple problem. You can easily see that 1/2 of this circle, which is the whole, but 1/2 of it, 1/2 of the 500 use a bike, and 1/2 of 500 is 250. 250 students use a bike to get to school.